Tyler Faith, I am so excited that you sat down with me in this hot seat interview for the Natural History Museum of Utah. I want to get to know you a little bit better. Can you tell me what you do here at the museum?
Yeah, I'm a curator of the archaeology collections here at the museum. I'm also an associate professor of anthropology on campus, and so we work together with both of those jobs here.
What do you specialize in here at the museum in archaeology?
Yeah, well, it's kind of complicated because, it's hard to put us in little boxes like that. I study relationships between climate change, animals, and people over geological timescales. A lot of my research is actually in Eastern and Southern Africa. I also study similar things here in Utah as well, but it's taken me across very different periods of time, but also very different places. But my main jam, I'm happiest in the lab playing with fossil mammals.
Fossil mammals, I love that. Lucky for you, I didn't prepare any questions about fossils, so we're going in a different direction. I hope that's okay.
We'll find out.
One of your areas that you focus in is the environment and how it changes due to climate change or interactions with people or animals. How does the environment influence how animals change or adapt to their surroundings?
Well, you've got a few options if you're an animal. I mean, the climate and environment are always changing, whether that's on short time scales or long time scales. You can move, you can adapt, or you can die. That's pretty much, those are the actions.
Great.
But I study the fossil mammals, especially in Eastern Africa, Southern Africa, because they can tell us about what's been happening with the environment through time, which in turn allows us to then say, okay, well, how are people responding to these kinds of changes? So they're great. A big key focus of my research is how we go from a bunch of fossils to understanding something about climate and environment, and then trying to link that to what's going on with human evolution.
So what can we tell about the future of climates and climate change based on the fossils that you study today?
That's a great question. And I think one thing to think of is our understanding of the world today and relationships between climate and animals and people. It's based on very short time scales. Typically observations over decades. If you're an ecologist or a zoologist and you're studying present day systems, a long-term study might be a couple of years. But when you start studying the past over thousands, tens of thousands, hundreds of thousands, millions of years, you start, the world is very different. Today is just a snapshot of this world of possibilities of what climates have looked like, what the environment has looked like. So there's a lot more out there, and by tapping into time, we can see how animals are responding to climates or environments that have no analog today. And that can give us a better understanding of how adaptable they are, how they might be responding to changes in the future. But a lot of what we think about how ecosystems work are oftentimes informed by just these very short-term views. And we provide that longer-term time depth to flesh it out a lot.
So do you have any personal predictions on what our environment will look like in 10 years?
10 years from now. Here in Salt Lake City.
Sure.
What I'd like is about this much powder all winter. Summer around 80 degrees. That'd be nice, I think. I don't think that's necessarily in the cards.
Sure.
It seems it's hard to tell, whether we're a short-term, year-to-year variation, and I don't yet have a good handle on it because I haven't been here long enough.
Sure.
But no, by most projections, warmer and drier.
What about worldwide? What kind of climate changes are we headed for in the next 1,000 years?
That's going to depend a lot on what we decide to do now. Moving into that, 1,000 years is, in the ways I think of things, just a little geological snapshot. For human societies, it seems like a very long period of time. If we look out the window over there, over the Salt Lake Valley and in the city and the skyline, and houses stretch as far as you can see, that is new. Humans, we as a species, Homo sapiens, we've been around for 300,000 years. We've been through very dramatic climatic and environmental changes, but never with populations this large. Ice sheets come and go, hunter-gatherer groups move, right?
Yeah.
Move, adapt, die, right? What do you do with the city? Right?
Yeah.
We've never really been there before. Interestingly enough, I mean, if the last million years were any indication of where we're headed, it would be very soon towards the planet would be plunging into glacial conditions. Sea levels would decline as the ice sheets in the northern hemisphere especially get bigger and bigger and bigger and bigger. And that's sort of been the story for the last million years. It's like 100,000 years of glacial, cool, relatively dry, and then this 10 to 15,000 year stretch of what we call an interglacial period, where the glaciers in the northern hemisphere aren't as large, conditions tend to be a bit warmer. We've been on this seesaw back and forth between these. But now the situation's different because we, humans, are playing a role in influencing climate. So in our absence, I would say, the time has kind of come. We've been in an interglacial for about 12,000 years. We should be trending back towards that. I'm not sure that's the direction things are going to go anymore. Certainly, the climate modelers, the ones who are best qualified to provide those projections, would suggest we may not be headed that way. What I find really interesting, though, is we as a species have to figure out how to cope with it, right? Like I said, our species has been through the whole range of things over hundreds of thousands of years, from sea levels 120 meters lower than present because most of the northern hemisphere is, large chunks of it are under ice sheets miles thick, right? But you move. And then the other end of the pendulum is not unlike what we see today. Sea levels are where they are. 125,000 years ago, sea levels were, in some cases, 10 meters higher than they were at present. But with smaller populations, you're more adaptable. Now we have cities. You can't really say, I grew up in Seattle, relocate Seattle because an ice sheet is coming down, right? Where would everyone in Canada go?
Yeah, sure.
So whether we're headed for that or a warmer and drier situation, we have to be, I think, adaptable, because moving is kind of out of the picture in some ways, but responding to those changes, I don't care which direction it's going to go. Stability has never been the norm in, ever. It's not. Climate and environment is always changing, and we've sort of hit this point with sort of the way our world works, where it kind of makes it hard to be adaptable. But I think it's something we will confront, or it'll confront us. There's no choosing.
If we have evidence of adaptability while these animals are changing with their environments, what do some of those adaptability characteristics look like? What do we see in the fossil record that would lead us to believe that these animals did adapt?
Yeah, I mean, that's a great question. And, animals are typically constrained by the resources that they depend on. You need food, water. If we look over long periods of times, you may see dramatic environmental changes. Where I work, do a lot of work in, say, Eastern Africa today, people might picture something like the Serengeti with these open grasslands dotted with acacia trees. Lots of wildebeest and zebras and gazelles on the landscape. You don't see that, say, 6 million years ago. That does not exist because there weren't extensive grassy plains anywhere. That's been a relatively recent development. And so you have these big ecological shifts, and animals respond to it. And how do they adapt? Well, if they're tethered to resources and you have new resources on the landscape, you can start changing your morphology, changing the way you move around that landscape. So a very typical shift we see in a lot of species over vast periods of time may be like dietary changes. You start eating different types of foods, and that in turn changes the morphology of your teeth, your jaws, how you're processing those foods. So that's one example. We might also see changes in the way animals are moving around the landscape. Migrating long distances if they need to track different resources, or if they don't need to, staying put, so that you can sort of adapt morphologically, you can adapt behaviorally, and that's certainly the case with our own species, no doubt. One thing that fascinates us when we're studying human evolution is we are not necessarily the only species to use tools in some kind of way, but we are dependent on it. I mean, you can point to examples of chimpanzees using tools, which is really interesting and tells us a lot about how the antiquity of when those behaviors may have come to be and what it might have looked like in the past if we go back millions of years ago. But they are by no means dependent on them in the way that we are. That's sort of one facet of human uniqueness. And it helps us adapt to change. If it's cold out, you put a jacket on, as opposed to, just imagine a long-term cooling trend. Yes, natural selection can operate on a species, and you end up with something, let's say a woolly mammoth, right? It's covered in fur, big fat reserves, well adapted for cold. We can adapt with our culture, with our behavior, which makes us much more adaptable because it doesn't require generations time. It can happen like that.
You're able to see within the fossil record positive pieces of adaptability, things that have made mammals, prehistoric mammals, change and survive and adapt to their surroundings. But what about not so great evolutions? Things that they adapted that didn't really pan out for them?
Well, I mean, most species that have ever existed will eventually have become extinct, or will eventually become extinct. I mean, that is the rule. And you can, I guess there are contexts you could sort of specialize yourself into a niche that disappears, right? And you are just too much of a specialist. And there's a lot of interest actually in sort of sorting out how we measure this. But there is a thought that some species may have sort of an ecological or behavioral strategy that does make them more flexible than others, whereas others tend to specialize in certain resources and they're really good at that, but if they disappear, the resources you depend on just disappear and you can't adapt, it's game over. So there are, yes, interesting questions and interesting research to be done about how sort of your adaptability as a species or as a lineage relates to patterns of extinction and speciation through time.
So I've loved hearing a little bit more about what you specialize in and what you do here at the museum. But I'd like to get to know you, Tyler, as an individual. So we will be playing a 60-second rapid-fire version of this or that. I just want your first gut reactions, no think, just answer. Are you ready?
Let's do it.
Coffee or tea?
Coffee.
Early humans or modern humans?
Early.
Beach or mountains?
Mountains.
Books or movies?
Books.
10,000 years ago or 10,000 years in the future?
Go.
Stand out or blend in?
Blend in.
Dine in or take out?
Dine in.
Sweet or savory?
Savory.
Sunny or overcast?
Sunny.
Holocene or Pleistocene?
Pleistocene.
Saving endangered animals or cloning extinct species?
Saving endangered animals.
Dessert first or dessert last?
Last.
Dogs or cats?
Dogs.
Spend or save?
Save.
Summer or winter?
Summer.
South Africa or Utah?
South Africa.
Ah, no, really? How much time do we have left? 10 whole seconds. We had 10 seconds
Keep
to
coming,
spare.
keep coming.
I don't
I
have
was
any
going to
other
say coffee before you even answered it, just because I wanted one.
That was the fastest we've ever been able to get through that.
It means I was giving you my honest answer.
Yeah, that was crazy. So you answered that you prefer South Africa to Utah, which just hurts my feelings a tiny bit, but I'll probably get over it. You just got back from a work trip to South Africa like 2 days ago. What's going on with that?
I spent the last better part of the last month working in South Africa on a few projects, helping some of my graduate students down at the U, getting set up working on some fossil collections from South Africa. And they've been going through, and someone has to say what animals these are, right? They come out of the ground, what is it? And they've been really great at that. I spent most of my time, and this will be a good one, climbing through the mountains with some colleagues. You're rock climbing and taking samples of hyrax pea. Hyrax, yeah, you've never heard that before. So hyraxes are like these small little furry mammals, like the size of a rabbit. Rock hyraxes live in rocky outcrops, and in the mountains, they'll hang out in these little crevices, and lots of them together. And their pea, everybody's got to go, right?
Yeah.
It mineralizes on the rock, and in places where it's relatively dry, you don't have rain, hitting it or water seeping through. Your hyrax you do your number one, pollen is blowing through the air, sticks to it, and that pea will mineralize. Again, over, say, 50,000 years. And you end up with these big piles of mineralized Irex pea, which 50,000 years ago, right up to the present, they're still doing it today. We can sample those and look at, recover the pollen that's preserved within it and understand what's been going on with the vegetation through time. And we can look at the chemistry of the pea itself to better understand what's going on with the climate through time. So the fun part of this work is you get to hike around the mountains a bit. They're oftentimes in like these inaccessible cliffs, so you're rappelling,
Wow.
down the sides of these mountains to get into these things and take out power tools. I mean, power tools and ropes, what can go wrong? And saw away and take off these big slabs of it, hike it back down the mountain, take it back to the lab, and do our stuff. So what we're looking at here is trying to generate records of South African climate over the last 50,000 years, hopefully, which we can then link to, this is part of a big project, some archaeological excavations that are going on simultaneously. And we're trying to understand sort of the environmental context of really important technological shifts that sort of sees this transition from a behavioral strategy that's associated with some of the earliest members of our species to something that's a bit more closely resembles what you might have seen in hunter-gatherer populations, say, 2,000 years ago. And there's a lot of ideas about how climate environment may have played a role in that behavioral shift. We need the data to test it. So that was part of what we were doing, was sawing off big blocks of mineralized pea.
I think you're living the dream here.
Yes.
I mean, is this your dream job?
I love it. I mean, you're paid to do your hobby. Is pretty much it. And I get to do lots of different things, work with a lot of fun people, travel to places that I like to be.
Hang out with little mounds of pea all
Yeah,
day. Love
yeah.
What did you want to be when you grow up, and how does it compare to what you're doing now?
I bumped into my kindergarten teacher like 5 years ago, and she said, what are you doing these days? Because he always said you wanted to be an archaeologist or a paleontologist. So, and I do both, so there we go. I think nailed it.
So what steps did you take when you were younger to prepare yourself for a career today?
I mean, it wasn't a conscious effort necessarily, like that interest I never shook it. And by the time I was, say, 18, looking to go into university, back then we had the big course catalog, phone book size thing, and going through, and everything I circled was like geology, paleontology, archaeology. And I was particularly interested in working in Africa and studying our own history by then, and I just did it. I mean, that was the, signed up to, in that, I signed up to be an anthropology major from the beginning, and just never stopped.
Clear goals, pure intentions, can't lose.
Yeah,
Love
and
that.
it really was. I mean, for a little bit, I dabbled in like taking the pre-med coursework, doing chemistry, physics, biology, because supposedly there's jobs doing that. And the first summer I was at the University of Washington, there was an archaeology field school, short little thing, just a few weeks. Went out, did it, and I was like, enough of that pre-med stuff. I'm hooked, I'm sold. So
Awesome.
that sort of reaffirmed what I thought I wanted to do, and just never stopped.
Well, Tyler, thank you so much for joining me. I've loved getting to know you a little bit better and hearing about your interests here within the Natural History Museum of Utah. So, what do we have on the horizon? Can we expect any new discoveries coming up or new papers that you're working on?
Oh boy. Yes.
That you can tell about?
Yes, that I can tell about. Well, oh geez, this is going to be almost tangential. No, I'm really excited. I have a new project that just got up and running. We just got some money from the National Science Foundation to pursue it, but we're actually shifting gears a little bit to understanding fire in their system. And specifically focusing on how herbivores, big animals that eat grass, for example, are influencing fire regimes. And ecologists have done a lot of work looking at conducting experiments, primarily in Africa, because you have diverse herbivore communities, but trying to understand, well, how the presence of herbivores on the landscape influences fire. And like we talked about earlier, the fossil record gives us there's so much more out there than just a few years or decades of observations. And so we're trying to sort of merge our understanding of the present as well as the past to really disentangle the extent to which we need to be thinking about how herbivores influence fire regimes, which is actually important for understanding how fire works on a global scale. I mean, savannas account for the majority of burned area on the planet in any given year. And that in turn, fire regimes play into the carbon cycle and trying to model what might be going on with Earth's climate in the future. And well, you got grasses and they're going to burn or something's going to eat them for the most part. And we're trying to disentangle some of that. So that's sort of where we're going. It's not, I've got nothing like in press that's going to blow people away, but hopefully we will in a few years.
Absolutely. I can't wait to hear more about that and see what the results of your research are.
Thanks so much, Eliza.
Well, thank you so much for joining me, Tyler. Any last words?
No, I've showered after this Hyrax thing. And mostly don't stink anymore. They used to use it in perfumes because it fixes smells. But it also, I've been musky for like 2 weeks.
I appreciate you making that effort before talking to me.
Hopefully I don't smell too bad.
No, this is awesome. Thank you so much, Tyler.
Right on.
I have one final question to leave you with. This or that. Would you rather smell like Hyrax pee for the rest of your life or be forced to turn into a Hyrax every full moon?
I don't think it smells that bad. I'm going with one.
We're going with pee? We're going with
Yeah,
Hyrax pee.
definitely.
Oh boy. All right, I applaud that charisma that comes.
There's a lot of cats in my neighborhood. I can't risk it.
Oh yeah?
Yes.
Yeah? That'll create some good tension. So I love that. Well, thank you so much, Tyler. We'll see you next time.
Thanks for having me, Eliza. See ya.